Good morning. Today we're going to take a look at the second part to geometric sequences. Geometric sequences were a sequence that have a common ratio between each of the subsequent terms. In other words, when you take the second term over the first term, the third term over the second term, the fourth term over the third term, and so on, you're going to get the same ratio. Kind of like when you had the same common difference with an arithmetic sequence. Add something to this first term to get the second term, or take the second term minus the first term, third term minus the second term, and so on. So we're going to take a look at a geometric sequence. The formula for the geometric sequence was a sub n. I'm going to write it down here. A sub n equals a sub 1, the first term, times, I'm going to go ahead and put it in parentheses, the ratio to the n minus 1 power. And that's the formula that we're going to be using as we take a look at this. All right? So, problem number 2. What are the second and third terms of the geometric sequence? All right, so right away it tells us it's a geometric sequence, which tells me then that I can use this formula. All right? So we're going to go ahead and box my formula. Oops. To give me what we're going to be looking at. And when you're looking at the second and the third terms, in this, you've got the first and the fourth given. All right? So as I'm looking at this, this is the first term, this is the second, this is the third, and this is the fourth term. So the first and the fourth were given. So as I'm looking at this, what I'm going to do is I'm going to take that fourth term. You want to avoid term 1. Okay, term 1's kind of confusing, and a lot of times you can get the wrong value for it, make a mistake, and still have the correct answer. Because you might get the impression, oh, then r is this, when in actuality it's not. So let's go to the fourth term. We will choose term 4, which is negative 54. All right, so what we're going to do is we're going to take a sub 4 and say, okay, that's negative 54. Right? And we will put that in to the formula that's up above. So we're going to take a look at that guy and put in negative 54, the fourth term, equals a sub 1. Now, that's the first term. So a sub 1, I'm going to say over here is 2. Okay, that was given. That came from this guy. All right. And we're going to have negative 54 using the formula. So now I'm going to go to the second. On the right side, it would be equals 2 times. Now, I'm going to look for r. So right now, we're just going to leave r as a variable to the, and then instead of n, I'm going to put in 4, because n is 4, it's the fourth term, minus 1, which should give me negative 54 equals 2 times r to the third power. First thing I want to do, let's get rid of the 2. We'll divide by 2. That'll give us negative 27 equals r cubed. And then we're going to take the cube root of r cubed to get rid of the cube. And that will cancel this and give us r. And I are not kidding. All right, so now we get the cube root of negative 27, and the cube root of negative 27 is negative 3. All right, there is one value there. So we now know r is negative 3. Now it said find second term. All right, we're going to go back up to my formula. And this time I'm going to use red. So we're going to go back to the formula for a2, a sub 2, arrow. I'm going to use a sub 2 equals, that's still my variable there, the first term, so 2 times, now I'm going to use this r, times negative 3 to the, and since I'm in the second term, I'm going to use 2 minus 1. Well, 2 minus 1 is 1. So this would be 2 times negative 3 to the first power, which would be negative 6, because negative 3 to the first power is negative 3, times 2 would be negative 6. So my second term is negative 6. Now to find the third term, let's go to a different color yet. Let's go to blue. So a sub 3 would be 2, again, the first term, times r we said was negative 3 times 3 minus 1, or squared power. So that's going to be negative 3 to the second times 2. Negative 3 to the second is 9 times 2, so a sub 3, I'm going to scoot over here just a bit, is positive 18. Okay, positive 18. So my second and third terms, this is second, and this would be third. And there's those answers. All right, you'll find one of those in the work set. Let's move on. What's the second term of the geometric sequence? All right, so I'm looking at this one. I could do the exact same thing. I can say that using again a sub n equals a sub 1 times r to the n minus 1 power. Okay, and again, don't use the first term, but let's find r by the third term. So let's go with a sub 3. So we'll say 12 equals, first term is 3, a sub 1 was 3, okay? And 12 equals 3 times r to the n minus 1. Since we're looking at the third term, this would be 3 minus 1, okay, a sub 3. So n is 3. All right, and then 3 minus 1, I'll highlight that. 3 minus 1 is 2. So we have r squared times 3 equals 12. Divide out the 3, both sides. And that will give me a 4 equals r squared. Then when I take the square root of r squared, I'm going to get r equals, don't forget, when you take the square root of a variable squared, you got to do a plus minus on this side. So we're going to get a plus minus 2. So what are the possible values here? R is plus or minus 2. All right, now to find my second term. All right, so let's use r is 2. So if r is 2, then we would stick into our formula up here, which is a sub n, second term, all right, which we don't know yet. We're trying to find. So we're going to go a sub 2 equals, first term, 3 times positive 2 for the first one, to the, and then again it's the second term, so in this one n is 2. We'll go with 2 minus 1, which is 1, which gives me an a to the second as being 6. 2 to the first power is 2, and 2 times 3 is 6. So there's the when r is 2. Now when r is negative 2, does it change? So a sub 2 would be 3 times negative 2. We've already done the negative 2, or the 2 minus 1, so let's just go with 1. Negative 2 to the first is negative 2 times 3 would be negative 6. So a sub 2 would be negative 6. So second term is positive or negative 6. You got two options there. And it works in this geometric sequence because we don't know. Geometric sequences can go positive, negative, and that's still geometric because the ratios will be the same. Or they can be positive. All right? So this one is a plus or minus. It's kind of like listing all possible, and that leads us to the next one, which I'm going to skip over the bouncy ball, come to this one. This is the one I was looking at, and that's what I had. I had a chip on there. Okay, so what are the possible values for the missing term of the geometric sequence? So 48, 3. This time, they wanted us to use the geometric mean, and this is a process that we've already looked at before. So setting up a geometric mean, I take my first term and my third term, and I'm going to put them in the places of the extremes. So this would be 48 is to some number, it's a geometric ratio, as that same number is to 3. And the geometric mean is this way. Remember, looking at the 48 and the 3 in this setup, when you're looking at a proportion, those are called the extremes. Okay, so this is the means, and it's a geometric mean. So if we multiplied those, did a cross product here, wow, that did not come out good. Let's try again. Cross product, we would get 48 times 3 equals x squared, or x squared is 144, which would give me, if I take the square root and the square root plus or minus, I'm going to get x is plus or minus 12. There is my possible values, plus or minus 12. Okay, it's another way that I can do, and I can do this when I've got the term that is right in between two other terms. Okay, kind of like this setup that's up here. All right, when it falls between, you can use this geometric mean setup. All right, which is the means. All right. Now, we're going to go ahead and back up and do that previous bouncy ball one. Oop, went too far. There we go. So when a ball bounces, the heights of the consecutive bounces form a geometric sequence. Right? So if I did the geometric mean that I just did in the last slide, I would take my 100 is to x as x is to 49 and get x squared equals 4900. All right? Or x equals, and this one has to be positive 70 because it's above, it's going up. So this is a 70 centimeters. All right, going this way. All right, and since I've got this set up, I can now use my ratio. So 70 is to 100 as 49 is to 70 as x is to 49. So I can set up this same scenario, and this is going to give me 7/10. This would be 7/10. And so this one needs to be 7/10. All right. So if I do my cross product here, so this would be the 1, 2, 2, 3, 4, and fifth bounce. Okay, so if I set this up, then I'm going to have a sub 4. Again, I'll put it up here again. A sub n equals a sub 1 times r to the n minus 1. So for the fourth bounce, this would be, the first bounce was 100 times, we just found that r was 7/10. To the 4 minus 1, which would be 3 to the third power, and that's going to end up giving me 34.3. Okay, and that would be centimeters. So that would be this mark in here. I'll change my color. I'll go to this purple, and I'll do my a sub 5, which would be 100 times 7/10 to the 5 minus 1, which would be to the fourth power. That didn't come out very good. To the fourth power, so 7/10 to the fourth power times 100 would be 24.01. And again, centimeters. So there's my fifth term, and here's my fourth term. And there's how you use the geometric sequence in this problem. Okay? That's just checking for r. And we found r was 7/10. Right. Any questions on that? Give me a holler. Take a look at your problems, and your homework will follow along with these examples. Hey, hope you're having a great week. Enjoy the weekend. Supposed to have a super day on Saturday, so enjoy it. See ya. Bye.